Okay, so what we're going to do today is we're going to make a force-sensitive resistor. What is a force-sensitive resistor? Well, essentially an FSR, or a force-sensing resistor, is a thing that you can press. This is going to be it. This is our super DIY one, where you press it, and the more that you press, the less resistance that it has. So it's essentially a resistor that loses resistance the harder you press. We're going to be using a 10K ohm resistor, and the harder you press, it can go down to 200 ohm resistance. So essentially, the harder you press, the more electricity flows through, and we're going to be using this construction to turn on this LED. What I want you to do is to grab some tin foil. I want you to grab, your bag of these wires. Grab just one. And I essentially want you to grab some scissors. And I want you to cut and turn it around. But I don't want you to press too hard. Just enough to score it until you're able to wiggle it loose and remove pieces of plastic. Next thing that you're going to need is some tin foil. So I cut some tin foil in this really poor way. It's however you need to. And then I used just some clear tape, just some Scotch tape, and taped one end of the wire with a little bit sticking out, enough for a alligator clip to latch onto. Inside is our black Velostat, which you have a whole giant sheet of, and then sandwiched with another piece of tin foil with Scotch tape and our wire sticking out. So what we want to do is we want to make sure that when we put our wire and we tape it, that there's not any air bubbles. So let's turn this over. The other thing that you're going to need, I almost forgot, is you're going to need two pieces of paper. This will work okay. Okay. So you actually really just want to sandwich it. Sandwich it between two pieces of cardstock. But right now we'll just have one. And we'll get two alligator clips. Red and a blue. Oops. And one side is gonna be your ground. Let's make this part our ground. One side is gonna be your power. Connect this here. Let's connect this. So the red is gonna go directly to power. So that's pretty easy. Don't have to worry too much about that. Oops. So we've got our ground connected to the breadboard, and what we want to do is in between our ground, we want to connect our 10K. So one side is connected to the resistor and the other side is connected over here, which we will connect to ground. Just use a mini, why not? Great, and then this side right here, we're just going to go ahead and connect that to an analog sensor because it's going to be receiving a value of information. Connection to A1. There we go. We are all wired up. Everything looks pretty good. And that's it. So let's get started. We have our FSR. Okay, our force sensitive resistor. So first thing we want to do is we want to initialize, or at least we want to establish where things are connected and what things will stay the same, right? Like we always do. So we're gonna connect. We're gonna start with our constant. That's int. Our FSR analog pin is equal. Oops, is equal to. I've put it in. Where did I put it in? A0. 0. Cool. Still. Okay. We want our LED. Oops. Yeah, it's fine. To equal to. Oops. Why do I always do that? What did I put it in? Pin 9 or something? Correct. Okay, pin 9. Okay, let's make this capital. Okay. We want to establish that we want to read the FSR. So let's go ahead and make that an integer FSR reading. Goodness gracious, spelling mistakes. Okay, we want to label it as such. Okay, so then we want to, since we have it in pin 9, we might as well create it as a PWM, a pulse with modulation. We want, since we have it connected to pin 9, the LED, might as well map it or create a situation in which we can map the LED's brightness, so we can essentially dim it or brighten it. Okay, so in order for us to be able to fade our LED, we want to call a variable, or we want to label the LED with brightness, or the variable that Arduino understands that allows for us to fade it up or down is called brightness. It reads brightness and it's like, ooh, fading. I know that term. I know what that means. Let's do it. I get it. So now let's go ahead and start our setup. And as per usual, we'll have our pin mode, LED pin set to output. We want to start our serial monitor, and as per usual, we have it set at 9600. Start the serial monitor. LED as output. Okay, and let's make our way to loop. And let's create our FSR reading, or we've already called it at the beginning this. So FSR reading, we want to, analog read our FSR analog pin. Great. And now we want to print it to our serial monitor. So print, we want to call this FSR SAR reading, why not, equal to, then we want to print in a whole new line our FSR, FSR reading. Cool. So now we want, to, of course, change the range. So like we usually do with analog pins that go into PWM pins, we have to map them from one into the other. So we'll need to change the range of analog info values from 0 23 down to the LED range, which is 0 to 255. Great. With map, like we always do. Okay, so, but in order to do that with LEDs, we want to call the LED brightness function. Remember that we labeled it as that at the very beginning. So LED brightness is going to equal to this map that we have created, 0, 123 to 0, 255, and we want we want the LED to get brighter the harder you press. So we're going to do analog right, because we've shifted the LED into PWM, and when we shift a digital pin into PWM, it takes analog right. It no longer is digital right. Digital is only high and low. Analog right is, of course, the range of values. Okay, so analog right, LED. Did I label it? No, I labeled it LED pin. LED brightness. Correct. Okay, let's delay 100. Why not? Let's see what that does. Let's make sure that all looks good. I feel like I probably messed something up here. Okay. See, look, I messed something up. What did I do? LED brightness. Too few arguments to function. Long int. What did I do? Oh, silly. Right. Okay. We need to map the FSR reading. Otherwise, it doesn't know what it's mapping as. So we need to map the FSR reading as 0, from 0 to 1023 to 0 to 255. Otherwise, it doesn't know what it's mapping. Cool. Got it. Oh. Okay, we haven't plugged it in. So oopsies. Let's make sure all of our ports are connected. Arduino Uno is connected. Cool, it is selected. And let's upload. All right, looks like it uploaded well. And let's come on over here and let's see if this works. There it is. Okay, you can see the less I press, there we go. And we see that let's bring our serial monitor back on. And you see it's about like between 200 and 180, or 250, let's say, and 180 is kind of like it's off, like lightly on. It sort of feels the pressure of the paper, but the more that I press, it goes up to 1,800, 900. Yep, about like 980, 975. Hard 1,000. Nothing. Get off my mountain. I'm also going to say that this drawing is by Mark Williams, which is an amazing drawing. I just have to share it because it's so cool. And this is an amazing drawing by Tom Sedgwick that I'm using for visuals because it's just so good. I thought it was kind of sweet. Okay, there we did it. We've got our FSR to work, made out of Velostat, and we got it to turn on a light bulb. We got it to fade a light bulb in and out depending on how hard we press. So that's pretty cool. And now let's move on to the next project.